All right, so let's go through this example here. It says, write the following recursion relation as a general rule and find the value after 20 iterations of the rule, so A of 20. So as you can see here, the initial value is 120,000, and then the next term is found by saying times 0.82 by the current term. It's really important that you can look at this and understand what exactly it's saying. So let's just put a little note here to ourselves. What this is saying is that we're losing 12% each iteration. Oh, sorry, not 12, 18%, 18% each iteration. Iteration. The reason why I know it's 18% is because 1 minus 0.18 is equal to 0.82. So in other words, when you go into a shop and they say, hey, you get 18% off, that means you're paying 82% of the value. So I'm losing 18% each iteration, which means that I'm taking 82% of the value each iteration. That's important that you just kind of look at that and you understand, oh, this is the calculation that's kind of going on just in the background. All right, knowing that I'm losing 18% each iteration, let's now talk about, how we're going to find the value of this after 20 iterations and why exactly we're going to raise it to the power of n as well, which remember is going to be our key question. Can I just take a moment to come off to the side? You don't have to write any of this down, but I just want you to really appreciate what we're about to do. Let's say I wanted to figure out the value of it after 2 iterations, so where n is equal to 2. And again, you don't have to write this down. I just want you paying attention. If I wanted to figure that out, what I could do if I was using my recursion relation is this. I would say, all right, I know that I start off with it being worth 120,000. I then times it by 0.82. I'll come over to my CAS. I go 120,000, 1, 2, 3, times it by 0.82. It's going to be 98400. That's when n is equal to 1. So that's after 1 iteration. Figure out after 2 iterations, I take this value, so 98400. I times it by 0.82. So again, it's losing 18% of its value. And I'm going to get 80688. So after 2 iterations, it's going to be worth this much. What I'm now going to show you is that what we've done here can be written in another way. So what we've just done here can be written in another way. I could have written it like this. To figure out when n is equal to 2, the value of when n is equal to 2, I could have done this. Let me just do that. Different one. I've got 120,000. I could times it by 0.82 and then times it again by 0.82. And if I was to do that, if I was to go 120,000, 1, 2, 3, times by 0.82, times by 0.82, as you see, what I'll get is 80688, which as you can see is what I got when I did it with the recursion relation. You might be thinking to yourself, how on earth did that work? How did this give me the same as what I've got up here? Let's just talk about it for a moment. And again, I don't want you writing this down. I just want you to take it in. Do you see that this right here, this 120,000 times 0.82, it's going to give me this value right there, right? Would everyone agree with that? Hopefully you do. And then what I'm doing to this is I'm simply timesing it by 0.82. And that calculation, this calculation, is what I'm doing here. And that's why I'm getting that as my answer. That's why this is the same as this. All right. Let me just clean this up a bit. Hopefully that makes sense as to why it is that we're doing what we're doing. Because now, understanding that this is the same as what we've seen up here, what we can now do is we can say, well, this can be written in another way. Because I've got 0.82 times 0.82, which I know can be represented as 0.82 raised to the power of 2. Because there's 2 of them. So this is going to be 120, 1, 2, 3. And that, of course, will give me this right here. Do you now see why it is that we're raising it to the power of 2? We wanted 2 iterations, so we raised it to the power of 2. Well, so too, let's just use another example here. Let's say we wanted to figure out the value when n is equal to 4. So after 4 iterations, that means I would take my original value, 120,000, and I would go 0.82 times 0.82 times 0.82 times 0.82. Because that's the same as going, so I'm starting at 120, 1, 2, 3, hit enter, times it by 0.82. I'm timesing it by 0.82 once, twice, 3 times, 4 times. And that's the same as going 120,000 times by 0.82 raised to the power of 4. 120,000 times by 0.82 raised to the power of 4. As you see, we get the same thing. That is why when we're about to, right now, create a general rule, you raise it to the power of n. So now when we come over here, and I want to write a general rule for this, I recognize that it's geometric, meaning it's times that. That means what I'm going to do is I'm going to say, all right, a of n is going to be equal to 120,123 times by 0.82 raised to the power of n, where n is the amount of iterations that I'm doing. If it now asks me after 20 iterations, I go a of 20 is equal to 120,000 times by 0.82 raised to the power of 20. I can come here, take this, make that 20, and I'm going to get my answer of 2267.035. I'll stop there. That's how you do it, people. That is why you raise things to the power of n when you've got a geometric sequence. So as soon as you see, oh, I've got a geometric sequence, that's when you've got to realize that you've got to do this. All right, hopefully that made sense.